prepare a water bottle and then place a cardboard on it and then place a random object on it. And this random object, it should be small enough for this experiment. Oh, and the next task is that you use your finger to remove the cardboard in between suddenly, quickly, and to see what will happen to the object you place it on the top. Oh, now, when you're holding a green object and then if you suddenly release your finger and then to release this green object, what will happen to it? Or it will fall into the bottle or it will fall downward. And why? What force make it to do so? And some of you may get the answer. It is the force of gravity. 咁啊，地心吸力啦，重力啦，係嘛？我指向邊度啊？指向地心。And because for this gravitational force or a force of gravity is a long contact force. So when we are drawing the arrow representing this object, it starts from the center of gravity of this object. And because this green cap is quite symmetrical in shape, so I assume that is at the middle of it. And secondly, as I mentioned, the arrow showing the force also show you the direction. Then what should the arrow point to? Okay, downward. 指向落啦，係咪？ And the third thing is that label the force. You can call it the force of gravity, gravitational force, or if you give it a more specific description, it is actually the force exerted by the Earth on this object. Well, and now I think you can see the overall effect of the forces acting on an object, because now there is only one force and this force is pointing downward, so that this force will make this green object to accelerate downward. And my question is, why don't we need to draw the bottle or the table? And just like this, we can call it the free body diagram on this green cap already. Why? It is because the idea of free body diagram is in order to show all the forces on an object and then to see the overall effect. So what we want to focus on is this green object, so that for the rest of the bottle, the desk, or the chair behind, we do not need to draw it. Oh, and let's see a more complicated case, and then I think you will have more understanding about what I'm talking about. Oh, in the second case, we again have our green object and then with a bottle. However, this time we place a card on the bottle and then put this green object or the random object you have on the cardboard. But this time, it will not fall down. Why? And obviously, the Earth is acting the force of gravity on this object. But why this time the green object remain at rest? What is giving it the support? 嗱，好明顯啦，地心吸力長時間都將你拉緊落去啦，係嘛？咁點解而家呢個 case 呢嚿綠色嘅嘢佢唔跌嘅？Oh, and you can have the idea that the cardboard give the green object a support, is it? Oh, and what should this force pointed to? This supporting force, upward, downward, to the right hand side or right hand side? It should give it upward force to support this object. So let's move on to the free body diagram of this green object in this scenario, and just draw the green cap, although I'm using a red pen. Then why do we need to draw the bottle, the desk, or the chair? It's because for this free body diagram, we would like to show all the forces acting on the green object only, but not want to show the forces acting on the rest of the object. So just draw the green object or the object you want to focus on or you want to analyze. Oh, and the first force is the force of gravity pointing downward, or we say that is the force exerted by the Earth on this object. Oh, then how about the supporting force? Well, it should point upward. Then how about the magnitude? 個數值係點啊？向上啦，數值應該係點？ Okay, it should be equal to this gravitational attraction in order to make this cap remain at rest, is it? Oh, and there are several important points. And because force of gravity is a long contact force, so when we are drawing it, you start this force from the center of gravity of this object. However, for the supporting force by the card on this object is a contact force. Where should it start from? It starts from the place that the green cap contact with the paper. So start from here and then pointing upward. And as I mentioned at the very beginning, the length of the force representing how strong the force is. Now, because you would like the supporting force cancel the effect of the gravitational force. So these two arrows should with the same length. However, they are opposite in direction. And I label it first. That is the force exerted by the card on the object. 咁而家見到一個向上，一個向下，係嘛？但係數值一樣，咁會點啊？抵消咗。好 and we call this case the net force equal to 0. And the meaning of net is that there may be several things affecting an object or several processes affecting an object. And in this case, there are several forces acting on this object. And after we consider all the forces, then the overall effect is what? And this time, because the two forces, they're opposite in direction, but with the same size, so that they cancel out each other. So we use the term net, and then because now the net force is equal to 0, so this object will remain its original motion state. And at the moment I place this green object on the cardboard, it is remain at rest, and there is no net force acting on it, so it will remain at rest. 靜者行靜. What happens if I suddenly remove the cardboard in between? What will happen? This is the case with the cardboard. So I suddenly remove the cardboard very quickly by my finger. Which of the force will no longer exist? Okay, the supporting force will no longer exist. That look like this. Then at the moment that I remove the cardboard, that is the cardboard flies away, what will happen? What is the net force? Is it still equal to 0? And this time, no. And this is the new free body diagram after I suddenly remove the cardboard. And as you may see, there is only one force acting on the object, and it is pointing downward, and it is the force of gravity. So the object will accelerate downward again without any support. So if you really perform this experiment at home, then the green cap or the random object you choose will fall into the bottle.